Hello guys, this video I'm going to show you how to solve triplet sum to 0. So given an array of unsorted numbers, 5 all unique triplets in it that add up to 0, right? So unsorted array we have here, right? 5 all triplets. Triplets mean 3 numbers, right? So as you can see, our output here array of subarrays. Each subarray has 3 numbers and all add up to 0, right? Okay, so this one is similar with the last one we solved in this category, and the previous one is pair of sum, right? Two sum. In that case, we need to find pair of numbers that add up to 0, right? But the array is sorted, so I think we can somehow convert this problem. We can translate this problem into the previous one, right? So in order to do so, we probably must first need to sort it, right? Sort it in ascending order, so it will become -3, -2, -1, 0, 1, 2. Okay. Six number here, so we should have another one here, right? Okay. So how about iterate for every number in this iterate for every number in this sorted array. So with each number we will need to find two other numbers in the remaining space, so that it complement with this one and add up to 0. It means the other two numbers must, for this case, add up to 3, so that 3 plus -3 is 0, right? So we have somewhat similar to the previous problem, right? So the first number here, right, will fix the first number, and our remaining space will be here. Okay, we have left and right. Now our goal is to find a pair number that add up to sum, which is 3, right? So here is 0 -2 plus 2 is 0, so it's too small, right? So we need to increase that amount by moving the left pointer rightward, because our race now is sorted, right? Okay, so now it's -1 plus 2 is 1, still too small, So one step forward. Now 2, it's still too small. We need 3, so move left forward one step. Now 1 plus 2 is 3, which is exactly what we need here. So we just simply save the current triplet, right? The first number that we have fixed, and 2 other that complements 1, 2. Okay. Okay, so now we find 2 two number that add up to 3, right? So one thing to notice here is that our array can contain duplicate here, so we probably don't want to process these, right? So for example, there can be a lot of duplicate here, like 1 and 2 and 2, right? And example here, x, y, z. So if we are here, then probably we don't want to process the duplicate numbers in case we have found the complement, right? The pair that sum up to complement of the target. In this case, we just want to go forward, right? Let's say we want to go ahead until the point that the current number is different from the previous, right? So it's for this guy is still the same as the previous, which is 1. So I will move forward until now, assuming x is different than 1, and we stop here, because if it's the same number here, it will produce the same result, right? It's still 1 plus 2, 1 plus 2, right? So same here. In this case, do we need to check x plus 2? No, because we have found out that 1 plus 2 is what we need. Then x plus 2 is for sure is not going to produce what we need, right? So we need 2 totally different numbers. So 2, 2, z, right? So that's how we proceed. And these 2 pointer will we will make this processing the finding the complement of the target number here until x is less than y, right? So in that case, we're done with the current number, right? But we still need to continue with the next one, which is in this case -2. Okay, we again back here assign the left and right. We don't need to count on the -3 anymore, right? Because we've exhausted all the possibilities starting with -3. So our left is now start from -1 and our right is from 2, right? Okay, our goal is now to find a two pair of number that sum up to the complement, which is 2 here. So 2 plus -2 is 0, right? So the same logic here. So let's try to code it down now. Okay, we need to sort our array first. We fix one number, right? We find the complement, find the pair, form remaining space that add up to complement of fixed number. Okay. This logic is pretty much the same as two sum, right? So instead of finding two numbers that sum up to 0, we find two numbers that sum up to a certain number, that complement with a fixed number to equal to 0. So for sort array, let's use a built-in function taking A and B. To sort it in ascending order, I'm gonna provide a hint which is A minus B. Okay, so fix one number is just simply by looping for every number. So for num of array, say kernum. Whoops, we need the index as well. So for let I equal to 0, I let an array dot length I plus plus. Okay, so let kernum is array at index I, and its complement is what is 0 minus kernum, which is minus kernum. Let's say minus num is -3, so minus num. Okay, so here's a complement. Our goal is to find find two numbers, right? So we start from left and right. Two pointer technique here. Left start from I minus 1, right from the last index, which is array the length minus 1. Okay, as long as left is still less than right, we want to continue. Okay, there are three cases here, right? If let's say current sum. Let's save it. Current sum is array at left plus array at right, right? So if current sum, there are three cases. If current sum e is equal to the complement else if current sum is less than complement else if and else is the current sum greater than complement. So for current sum that is less than complement, it means we need a bigger sum, right? So we move the left pointer rightward, left plus plus. Okay. If current sum is greater than complement, we need a smaller number, so we move the right pointer leftward. In this case, it means we have found a valid pair number, so we need to save it into somewhere. So we need to store the output is an array, empty array here, and finally I'm going to return the output. Okay, so if the current sum equal to complement, it's a perfect pair number, so we save it. Output, we push it. We push three numbers: the fixed one, which is current number, and two others that sum up to complement. So it's array left and array right. Okay, and as we discussed earlier, there can be duplicate here. So we probably want to loop, right? As long as the left as long as left plus one, no, array left plus one, the next number is still equal to current number, array at left. Then I'm gonna move the left rightward, so left plus plus. Right? Same for the right pointer. Array at right minus 1 equal to array right, then right minus my move to the left, so minus subtract 1, right, on the right. So you might think that this is correct, but actually it will produce infinite loop here. The reason is because, for example, we start from right here, right? We check the next number is 2, so it's equal. So we want to go in here into the loop. So we subtract right by 1. Okay. Again, come back to the condition check here. Array at right minus 1 here is still equal to value at current right, so we subtract again, right minus minus. Okay, so now we come back here, we check it again. Array at right minus 1 is z, assuming that it's different than 2. It means it doesn't satisfy this this check anymore, so we exit our loop, right? And we exit this block, continue processing. And same here, as you can see, we end up at 2. We ended up at 2, and it should not be the case because we end up at z instead, right? Same here, on the left side we will end up at 1, right? So this is not something that we want. We want that left and right end up at x and z instead, right? So this can be a mistake, one mistake that you might face along the way. So let's fix it by how we can fix it here. One way to fix it is to move the pointer first, right? One step first. Right minus minus, and we want to check there's different way here. I think we can, here we kind of check here we check backward, right? No, we check the next number, the current left with the next number, right? So now my idea is to doing different here, which is we check the current number with its previous, right? So that it will stop when the current number is different than previous, right? So current number should be array left, and here the previous number is on the left, right? So it should be left minus 1. If this is the case, we want to increase left, right? And if same here, right, and previous is previous at index right plus 1, then I'm gonna move forward. So before doing this, before jumping into the first check here, we must increase left and right by 1 first. Now left will be moved to the right to be we move right to the left, so left minus we subtract 1 from right, right? So this should be working, I think. So just 2, okay, 4. Okay, it works. So that's it for triplet sum to 0 with 2-pointer techniques. But of course, before it's not easy as 2 sum. We need to sum. We need some process, pre-processing. We need to do some work to bring it back into 2 sum problem, right? So that's it for this video. See you in the next one.